Hello students. So in this lecture I am going to discuss another type of photoemissive cell, that is gas filled photoemissive cell. So in the last lecture I discussed about vacuum type photoemissive cell, and I told you that the sensitivity of vacuum type photoemissive cell or vacuum type photoelectric cell, the sensitivity of that type of cell is very low, or you can say it is moderate. So in order to increase the sensitivity we search for more options, and we have this gas filled photoemissive cell as well as this photo multiplier tube. So in this lecture I'll be discussing about gas filled photoemissive cell, which increases the sensitivity of vacuum type photoemissive cell. So, how it increases the sensitivity in gas type photoemissive cell? What happens? The construction of gas type or gas filled photoemissive cell is exactly similar to that of vacuum type photoemissive cell. The whole construction remains similar, except the difference is there is an inert gas at a pressure of 1 mm of Hg, which is introduced into this glass envelope. In vacuum type photoemissive cell, what happens? This glass envelope is evacuated. We use the evacuated glass envelope. We we take the whole arrangement and mount into the evacuated glass envelope in vacuum type photoemissive cell. Whereas in gas filled photoemissive cell, the whole construction remains same. The only difference is we use the inert gas at a pressure of 1 mm of Hg and introduce that inert gas into this glass envelope. So this is what gas filled photoemissive cell. Now what happens, as I've told you, in vacuum type photoemissive cell, what is the process? This is the cathode, that is this thin metal fin with the photoemissive material coated on its concave surface work as cathode, and this rod work as anode. Now what happens when the light radiation strike this photoemissive surface or the cathode part? What happens? The light radiation strikes this photoemissive surface, electrons emit out depending on whether the photon energy, the energy of photons is greater than or how much it is greater than the band gap of that photoemissive material. So depending on that, the electron emission takes place at the cathode. Now the amplification of the emitted electrons at cathode is amplified. Again, I'm telling you what happens. The electrons that are emitted at the cathode, because of the light radiation striking the photoemissive part of the cathode, the emitted electrons get amplified in the gas filled photoemissive tube. So how the amplification takes place? What happens? We use a inert gas inside this glass envelope. Now, as I've told you, we use this circuitry for the photo cell or photoelectric cell, where this is the photoelectric cell. We use a battery here. We close the circuit. Now if we increase this voltage, now the circuit will remain same in case of gas filled photoemissive type tube also. The circuit will remain same. We will use a gas filled photoemissive tube here, the battery here, and the circuit will be same like this. Now how we are actually amplifying using the gas filled photoemissive cell, that part I'm going to discuss here. What we will do, what happens here, we increase the voltage. Now depending on this voltage, when we increase the voltage, the electrons emitted at the cathode part get accelerated. Now these accelerated electrons, they collide with the atoms of this inert gas. Now on collision, ionization occurs and further electrons are produced. This further electrons produced actually amplifies the electron emission. The electron emission gets amplified, and we can say the photoelectric current gets increased. Again, I am repeating what happens. The electrons that are emitted at the cathode part, because of the light energy striking the cathode part, when these electrons get emitted. Now if we increase the voltage, what will happen? These electrons will get emitted, electrons will get accelerated. Now since in gas filled photoemissive cell there is an inert gas in this glass envelope, there is an inert gas, so this accelerated emitted electrons, they strike or they collide with this atoms of the inert gas, and upon collision ionization occurs, and further more number of electrons are produced due to this collision process, and because of this photoelectric current gets increased. This is how we are actually increasing the photoelectric current using this gas filled photoemissive cell compared to the vacuum type photoemissive cell, that is by amplifying the electrons emitted at the cathode using this inert gas. So this is how the whole procedure takes place using this gas filled photoemissive cell. Now since the photoelectric current gets increased, obviously the sensitivity of this gas filled photoelectric cell will get increased. The sensitivity will also increase, and this gas filled photoelectric cell provides a gain over this vacuum type photoelectric cell of about 5 to 10. So because of that, the gain, obviously the gas filled photoemissive cell is producing a gain, it's providing a gain over this vacuum type photoemissive cell, or we can say that the sensitivity is getting increased because the photoelectric current is getting increased because of this gas filled photoemissive cell. So the luminous sensitivity gets increased, and it falls in the range of 40 to 150 microampere per lumen. 40 to 150 microampere per lumen, which was initially 10 to 100 microampere per lumen for vacuum type. Initially for vacuum type photo cell the sensitivity was this, and because of the gas filled photoelectric cell, because of this collision process, because of this ionization process, the sensitivity got increased because the photoelectric current got increased, and the sensitivity increased to 40 to 150 microampere per lumen. So this is the luminous sensitivity, and the radiant sensitivity will also get increased, and it will lie between 0.01 to 0.15 microampere per microwatt, which was initially for vacuum type photoemissive cell, it was initially 0.002 to 0, it was 0.0022 to 0.1 microampere per microwatt. So this was the radiant sensitivity in case of vacuum type photocell, and because of this gas type photocell, this radiant sensitivity got increased to this 0.01 to 0.15 microampere per watt. So this is how gas type emissive cell or gas type photoelectric cell increases the sensitivity over this vacuum type photoemissive cell, just by because of the just because we have introduced a inert gas in this glass envelope. Now this is the characteristic of gas filled photoemissive cell. This is the characteristic. Here you can see the change of anode current, or you can say the photoelectric current with the change in anode voltage, or that is the applied voltage. Means this is the applied voltage, EB is the applied voltage, and the photoelectric current. So this is what I have shown here in the characteristic curve. So this is the characteristic curve. Now here again this whole circuit can be this circuit can be used for measuring the luminous flux intensity for gas filled photoemissive cell also. Just as we know, the photoelectric current depends on three factors: intensity of light and color of light or its wavelength, and voltage applied between cathode and anode. So if we make the color of light or its wavelength constant, if we apply a constant voltage between cathode and anode, then the circuit can be used for measuring the luminous intensity of the radiation. So this is if we make the anode voltage constant. Let me take this anode voltage, and for a constant wavelength, this graph is for a constant wavelength. So for a constant anode voltage, you can see depending upon the luminous flux intensity, the anode current is getting varied. So anode current is we can completely find the luminous flux intensity using that circuit. Now from here you can also see one thing, that there is a critical value for gas type photoemissive cell. There will be a critical value for applied voltage. Means, as I've told you here, in this circuit, this circuit will be used for measuring the luminous flux intensity, and we are increasing this voltage so that the electrons get emitted here in the photoemissive cell, and the collision occur and the amplification of electrons will occur. So if there is a critical voltage for this applied, a critical value for this applied voltage, which depends on the tube geometry, gas filling and illumination. Depending on these three factors, there will be a critical value of this applied voltage. Now if the voltage exceeds, if the applied voltage exceeds that critical value, then what will happen? Collision will increase, excess number of electrons will get amplified, excess amplification will occur, and a glow discharge we will get to see a glow discharge inside this gas filled photoemissive cell, and this glow discharge will destroy this cathode. We may damage this cathode. So in order to prevent this, in order to prevent our gas filled photoemissive cell, a resistor should always be connected in series with this gas type photoemissive cell. What this series resistor will do, it will limit the current. In case an accidental over voltage is applied here, this series resistance will limit the current that will flow because of this phototube. So advantage of this gas type photoemissive cell is, obviously it will increase the sensitivity over vacuum type photoemissive cell, and disadvantage of this gas type photoemissive cell is thus it is not as stable as the vacuum type photoemissive cell, because it is not stable. And the second disadvantage is the characteristics. As you can see here, the characteristics are non-linear. So these are the disadvantages of gas type photoemissive cell. In the next lecture, I'll be discussing about the photomultiplier tool, which will further increase the sensitivity of this photoemissive cell, So I'm ending this class here. Thank you.